Hello everyone. We have been discussing the basic concepts of chemistry, and in that discussion we were discussing some numericals. We were discussing about the concentrations, its way of expressions, and the numericals related to that. Numericals are really important, but before that, before starting this discussion today, I would like to congratulate all the students who has done well in the the result that has came out recently, and to all the students who has not done so much well, or who are not at all happy, although I think most of you have done well. Those who have done well and those who have not done so well, my message is for both of them. See, class 10 result, yes, it is important, but at the same point of time you must realize that along with class 10, the bigger exam, or a much tougher exam, or you can say a bigger test, is coming in front of you, that is in form of class 11. Whoever is going through this video, either you have taken either PCM or PCB combination, right? So you have to go through a really tough schedule, tough times obviously we are facing, and at the same point of time the harder level of facing the problems, because PCM or PCB is all about facing problems, that will be much bigger. But on a, I would say, on a happier note, or on a hopeful note, I would say that the problems that we are going to face will be interesting one. This journey will be really very good, because if you show interest in all these subjects, the way of finding out the happiness through learning is there. But you need to find out, and you have to put yourself, you have to devote yourself fully into these particular concepts of each and every topic, so that you understand the topic, then only you can find out the happiness while reading it. So again, I would like to congratulate one and all who have been watching this video, all the students of the class 10 pass outs, and at the same point of time we have to focus ourselves back into the topic that we have been discussing. So like the previous day, we will continue discussing the numericals of this particular chapter, which we have been already doing. So let's see. So let us start solving problems. So the first problem for today is like this one. The question is, the question goes like this: what volume of 6 molar HCl and 2 molar HCl should be mixed to get 1 liter of 3 molar HCl. Now, while solving this, first of all my suggestion will be to go through the question once again. See, it is a mixture of acid, right? Volume of 6 molar HCl and 2 molar HCl will be mixed. So the final one will be 3 molar. So suppose what we can say is the volume of 6 molar HCl required is X liter. Say, so obviously if it is X, so for 2m it should be, so volume of 2 molar HCl required will be 1 minus X liter. So if we apply this logic in the molarity equation, it should be written as M1V1 plus M2V2 is equal to M3V3, which is the final one. So here you see M1, that is 6 molar, V1, how much it is already known, it is how much it is? This one is only x plus m2, that is 1 sorry, m2 is given, it is 2 molar, so I can write only 6 only, so it is 2 molar into 1 minus x. It should be is equal to 3 molar 1 liter solution, so it should be 3 molar into 1 liter solution. So from here only we need to calculate the value of x, so it should be 2 plus minus 2x is equal to 3, like this. So 4x should be is equal to 1, x should be is equal to 1 by 4. 1 by 4 means obviously it should be 0.25 liter. So what volume of 6 molar HCl that is required? So for 6 molar HCl, the volume that we are getting is 0.25 liter, and for 2 molar HCl it should be 0.75 liter, because 1 minus that only. So this is how we have solved our first problem. Now let us move on to the next one. I hope you have understood. You write it down. Let us move on to the next problem. The question is, a sample of NaOH, sodium hydroxide, weighing 38 gram is dissolved in water and the solution is made to the solution is made to 50 milliliter in a volumetric flask. What is the molarity of resulting solution? So let us face this problem, and at the same point of time there is another part which is given. So this is the first part of this question. The second part suggests how many moles of sodium hydroxide are contained in 27 milliliter of 0.15 molar NaOH. So let us solve both of these one by one. These are standard problems. We may have to face the same or similar problem at the time of examination. So let us face this. So in the first case, as you can see, sample of NaOH has been this gram is dissolved in solution made to 50 ml. So the volume of the solution is given. So we are talking about the first one. Volume of the solution is 50 ml. We have to find out the molarity. So first of all, number of moles of sodium hydroxide should be given mass divided by molar mass. Given mass here is 38 and molar mass of sodium hydroxide, if we check simultaneously NaOH, it should be 23 plus 16 plus 1, so it should be 40. So this is the given mass by molar mass and this is the number of moles of sodium hydroxide. Now as far as the molarity is concerned, So we can calculate molarity, number of moles of NaOH divided by volume of solution in liters. If it is in ml, in this particular case it will be multiplied by 1000. So number of mole 38 by 40. Volume is how much? Check the volume, 50 ml. It's 50 into 1000. Now you are supposed to calculate this part. I have calculated it already. I am getting it one as 19 mole. So this is the answer of the first question. What we have done is number of moles of sodium hydroxide divided by the volume of solution. If it is in liter, you do not have to change anything, but because it is in milliliter, you have to change into 1000. Next is the question number B. So let me erase it first. You write it down. Let me erase it. The second part is how many moles of NaOH are contained in 27 ml of 0.15 molar NaOH. Similar thing. Remember, molarity is equal to, you can write like this, number of moles of NaOH divided by volume in milliliter into 1000. What are the values that are given? 0.15. Molarity value is given. N of NaOH we have to determine. Volume is also given, 27 that is, into 1000. So it should be number of moles of sodium hydroxide is equal to 0.15. It should be into 27 divided by 1000. So how much we are getting? You should calculate. We are getting 4.05 into 10 to the power minus 3 moles. I have calculated this one previously, but you should do it by yourself. So these two are very, very standard case where we have seen how to solve this type of problems related to the molarity. Now let us shift our attention to a different type of problem. The next problem goes like this. Question is, a mixture of aluminium and zinc weighing 1.67 gram was completely dissolved in acid and evolved (1.69 liter) of hydrogen at STP. What was the mass of aluminium? What was the mass of aluminium in mixture, in original mixture? So let's see how can we deal with this. First of all, first thing first, it is a mixture of aluminium and zinc. So aluminium and zinc, these are mixed. And after the formation of mixture, it is how much? 1.67 gram. Completely dissolved in acid. Which acid? So it is it mentioned here? No, it is not mentioned. So suppose we take HCl, that will be easier for us. So first thing, aluminium, when it reacts with HCl, what do we expect? It will give rise to the formation of aluminium chloride plus hydrogen, right? And zinc, will do the same. Zinc can also react with HCl, will give rise to ZnCl2 plus H2. Now as a matter of fact, we have to balance it. So if it becomes 3, then it will be difficult to manage. One thing we can do, we can make it 3 and we can make it 6, I think. In that case, this will be 2 and this will be 2. This is what we can do. And in the second case, balancing will be much more easier since there are 2 hydrogens on. So now, what mass of aluminium we have to calculate? So let the mass of aluminium is x gram in the mixture. So what we can say is mass of zinc should be how much? This is the total mass, so it should be 1.67 minus x, this much. Now from this what we can see? You will see it is 3 mole, right? So it is 3 into 22.4 liter. We are getting this from 54 gram, right? And similarly, zinc is 65.3 gram and it is giving rise to the formation of 22.4 liter. These are the basic informations that we are getting. Now, whenever we are going to calculate, obviously 1.69 liter of hydrogen is being produced. 1.69 liter. And we should calculate like this. If 54 gram of aluminium produces 3 into 22.4 liter of hydrogen, then x gram of aluminium will produce 3 into 22.4 divided by 54 into x liter of hydrogen. Similarly, simultaneously we should calculate that 65.3 gram of zinc produces 22.4 liter of hydrogen. Now, how much of zinc we have taken here? It is 1.67 minus x because the mixture is 1.67. Aluminium is x, so remaining is zinc. So 1.67 minus x gram of zinc produces 22.4 divided by 65.3 into 1.67 minus x liter. Now try to understand that x gram of aluminium produces this much amount of hydrogen and this will produce this much amount of hydrogen. So this is the contribution from aluminium and this is the contribution of zinc, and in total it is basically producing 1.69 liter. So simply what we have to do is 3 into 22.4 divided by 54 into x plus 22.4 divided by 65.3 into 1.67 minus x. The addition of these two is equal to how much? The addition of these two is equal to the total volume, which is 1.69 liter. So from here we have to calculate the value of x only. So you have to calculate it carefully. I have done it previously though, so I am writing it directly, but you should be calculating. I am getting x, value of x as 1.23 gram. So if I am getting the value of aluminium as 1.23 gram, so obviously this is for aluminium. So for zinc it should be 1.67 minus 1.23. So this should be how much? 0.44 gram. So very interesting problem, let us have a revisit of this problem. Here aluminium, zinc, both are mixture, which is total weight is this much, gives rise to hydrogen gas. We know metal, when it is mixed with acid, it will give rise to hydrogen. So we have formulated two reactions based on that, first one and second one. Then we have seen the weight to volume ratio based on the mole concept. So first aluminium we have chosen as X and zinc we have chosen as 1.767 minus X. 50, as per the equation, 54 gram of aluminium, because 2 into 27, remember it should be 2 into 27 actually, gives rise to this much of hydrogen. So X gram of aluminium will give this much of hydrogen gas. Similarly, 65.3 gram of zinc will give 22.4 liter. So 1.67 minus X will give how much? Accordingly we have written. So addition of these two, the hydrogen produced from aluminium and the hydrogen produced from zinc, if we add these two, we are getting 1.69 liter. So that is what we have done at last. We are getting the value of X. I have written it directly. You should calculate from here. Then we are getting the value of zinc also. So we are getting the individual mass of aluminium and zinc based on this, all these processes. So carefully go through these numericals. Similar problems we will be solving in the live interactions.